This is the second podcast on naming and writing compounds. We're going to be focusing on binary ionic compounds, also ionic compounds that are not binary, and then we're also going to get into covalent compounds. So let's start off with the binary ionic compounds. Again, remember that binary means two. So binary ionic compounds, we will have two elements, a metal and a nonmetal. Remember from the last podcast that the compound must be neutral. With ionic compounds, we balance charges. So let's look at some examples. The first one, sodium chloride. Sodium has a symbol of Na. Sodium is found in group 1A. It has a positive 1 charge. Chlorine is Cl. Chlorine is found in 7A. Has a negative 1 charge. If you notice, my charges are balanced. Positive 1 and negative 1 cancel each other out. Therefore, we do not need to bring in multiple charges to balance this compound out. So NaCl, we leave it like that. Next example, calcium fluoride. Calcium is Ca. We find calcium in group 2, so it has a positive 2 charge. Fluoride is found in group 7, has a negative 1 charge. Now if we look at this example, our charges are not balanced. So for us to balance them, I'm going to bring in another fluorine that has a negative 1 charge. So now I have two negative 1 charges, which equals negative 2. Now looking at these charges, they are balanced. So to write the formula, I have 1 calcium and I have 2 fluorines. So you write the number that you have down at the bottom. Example number 3. The symbol for aluminum is Al. Aluminum is found in group 3, has a positive 3 charge. Oxygen is found in group 6, has a negative 2 charge. My charges are not balanced. If I were to bring in another oxygen, that makes negative 2. If I bring in another aluminum, that makes positive 3. If I bring in a third oxygen, that makes negative 6. So now I have a positive 6 and a negative 6. So we write how many of each element we had to bring in. 1, 2 aluminums, 1, 2, 3 oxygens. Now writing the names. Sometimes in chemistry, we have to deal with those metals that are in the middle of our periodic table. Those metals are called transition metals. If you were to look at the periodic table that I had in my classroom, the big large one, you would see in the top right hand corner that those transition metals have multiple charges. So to distinguish the difference between what element we want with a positive 2, positive 3, etc. charge, we have to use Roman numerals. So for example, what would a chemist name the compound CuCl? Looking at my periodic table, I'll just hold the one up I have here. If you look at the middle section, copper is found right here. It is in the transition metal section. Since it's found in the transition metal section, we need to use a Roman numeral to identify the charge of the element. So I am going to write down, just like before, we write down the first element, as it is, it's copper. Write down the second element with an IDE, chloride. However, we need a Roman numeral to identify what copper I'm talking about. If you look over here on the right-hand side, you see that copper is listed here in 2 forms, a positive 1 charge and a positive 2 charge. So to decide what Roman numeral we need, I need to look at chlorine, find its charge. Chlorine has a negative 1 charge. So to balance it out, copper has to have a positive 1 charge. Therefore, the Roman numeral 1 goes in the parentheses. So copper 1 chloride. All right, next example, CuO. Cu again is copper, needs a Roman numeral, and then O is oxygen. I list it second as oxide. Oxygen is found in group 6, has a -2 charge. Therefore, this copper has to have a +2 charge. So I put Roman numeral 2 in parentheses. All right, try number 3. I'm going to pause it right now. I want you to pause it right now so that you can work on it and then restart it once you have finished. All right, what is the name of AlCl3? Al is aluminum. Cl is chlorine. I listed chloride. Now, this one was a trick one. You should have seen that aluminum is not a transition metal, therefore it does not need a Roman numeral. Moving on. Not all ionic compounds are binary. Polyatomic ion is a positively or negatively charged, covalently bonded group of atoms. To name a compound that contains one of these ions, first you write the name of the positive ion and then write the name of the negative ion. You are supposed to have picked up the chart that is the name of polyatomic ion. So let's look at this. Name the following compounds. So if you notice, this is not binary. That should be your clue. I have 3 elements, not 2. So I need to look on my polyatomic ion list. Let me pull it up here. And find my NO3. So here's the list. You should see that NO3 maybe is right here. It is nitrate and it has a -3 charge. So go back here. I am going to name this lithium nitrate. Now I want to look, where is lithium found on the periodic table? Okay, lithium's found in group 1, so it does not need a Roman numeral. All right, moving on. K2SO4. K is potassium. Potassium is also found in group 1. I do not need a Roman numeral in the name. SO4, I'm going to look on my list. SO4 is right here. It's called sulfate. Sulfate. All right. Now look at this one. This one I have 4 elements. So actually, I can find both of these polyatomic ions on the list. NH4 is right here. It is ammonium. SO4 is down here, and it is sulfate. All right. Now next, CuClO4-2.
Excuse me, screen flow 3.0.8 needs your attention.
All right, this last compound is copper, chlorate. We need to go to the polyatomic ion list to see what the charge on this compound is. Chlorate is a -1, so copper would be a +1. Now to writing the formulas. Aluminum hydroxide. Aluminum has a +3 charge. Hydroxide has a -1 charge. So when we form our compound, we have to balance the charges. Aluminum, OH, with a subscript of 3. We need 3 negative charges to balance out the +3 charge on the aluminum.
There you go, there's 3 bags for you.
Try the next 2 compounds on your own. Now, going over to covalent bonds. Covalent bonds are much easier than ionic bonds. You just need to use the prefixes to tell what compound it is. So starting with antimony tribromide. Antimony, the symbol is SB. There is no prefix, meaning there is 1. Bromide is BR, and it says tri. Tri means 3. So we would put a subscript of 3 on that compound. Next example, hexaboron silicide. Boron is B. Hexa, we look at our prefixes, is 6. And silicide is silicon, which is Si, no prefix. There should be a mono on the second element, which means 1. Next compound, chlorine dioxide. Chlorine is Cl. Dioxide, oxide is oxygen. Di meaning 2, so there would be a subscript of 2 on oxygen. Try the last one yourself. Now, just the opposite, we are going to look at the formula and write the compound, starting with P4. 4 is tetra. P is phosphorus. S is sulfide. There are 5 of them, so pentasulfide. The next one, Se, is selenium. There's only 1, so since it's the first element, we do not need to say monoselenium. And then F is fluoride. 6 is hexa, so hexafluoride. Go ahead and try the next. This completes the round 2 of naming and writing compounds.